Right. Here with Joe Pecorelli.
Well, I'm really glad I'm here.
What was it that you wanted to get from the conference, and what is it, like, the key message that you want to send to people? Derek Evans from AFBI, Agro Food and Biosciences Institute.
Sorry, excuse me. So I've got about 10 minutes, I think, to try and cover a decade's worth of monitoring contaminants in eels at the Scottish Environment Protection Agency. So it's going to be fairly quick and brief, I'm afraid, but hopefully I can stay around for the Q&A session and answer any questions there. So first of all, some background. Monitoring of eels in the environment for contaminants predates SEPA, and at SEPA, the work looking at contaminants in eels started in about 2004, and then from 2008 onwards, we started looking at contaminants in brown trout and salmon as well. And there are several drivers for doing this. Obviously, we want to know something about the state of the environment with regard to contaminants, but there are also international agreements and various other drivers that mean we need to do this sort of work. And I should say we were looking at contaminants predating freshwater biota way before that, mainly marine mussels, but we're also looking at sediments as well. So when we started thinking about monitoring in eels, we decided that we needed some ground rules because of the conservation status. So we decided there wouldn't be any new sites introduced, and that sites would be used a maximum of once every 3 years. Obviously, as I said, we're interested in the risks that these sorts of contaminants present to these organisms, but also risks in the food chain, which I'm going to talk about a bit on this next slide, I think. So we're particularly interested in chemicals that have a combination of properties. So chemicals that persist in the environment, bioaccumulate in organisms, so that means they increase in concentration as you go up the food chain, and obviously that are toxic. So this basically means as you go up trophic levels in the food chain, your chance of some kind of population-relevant impact increases. But we're also very interested in the kind of effects in the food chain that aquatic predators might experience from high doses of these chemicals, and also the human food chain, although that's maybe less relevant, arguably, for freshwater fish. Yeah, and looking in biota, another reason you might want to do this is it's very good for monitoring long-term change in the environment for contaminants. Obviously, concentrations in the water column are very transient, so looking in biota gives you a very good idea of how things are changing over a much longer period of time. And also, there are various practical difficulties with these sorts of persistent bioaccumulative and toxic chemicals. They're usually really poorly water-soluble, so they partition into sediments and biota. So if you're looking in biota, you're kind of looking in the right place for them. So some examples of the chemicals that we have looked at over time, they're mostly what are called legacy persistent organic pollutants. So there were various international agreements banning or massively reducing the use of these sorts of chemicals, and they include organochlorine, pesticides, and various industrial chemicals, the most notable of which are probably the PCBs, which are polychlorinated biphenyls, and polybrominated diphenyl ethers, the PBDEs. And there are loads of these things, and it sort of depends on how much chlorine or bromine is in the molecule. I've got some structures on the right there. I don't know if anybody's so familiar with chemistry, but that gives an indication of the sorts of chemicals we're talking about. And these things have been used for many, many years. Most of those pesticides listed, in fact, all of them are banned, but they do continue to persist in the environment because of their longevity. Other contaminants like heavy metals and polycyclic aromatic hydrocarbons, looking in fish for those is not so good. Many of the metals don't accumulate massively beyond certain trophic levels when fish are able to regulate the amounts of them in their bodies, and PAHs become more liable to metabolism with the sort of higher trophic level of fish. So those are the sorts of chemicals that are better suited to sediment monitoring. Okay, trying to make these move on. Thank you very much. So when we were thinking about what species to monitor, I keep looking up there, I should turn my bits of paper. We had sort of several criteria that we were thinking about as we did that. So obviously we were thinking about existing monitoring, conservation status, and the practicalities of sampling fish. So we were thinking about how widespread they were across the Scottish water environment, but also how big the sample would be, because you need a certain amount to do chemical analysis, because unfortunately it's destructive sampling that we have to do. We also had to think about trophic levels, so fish around about trophic level 4 are ideal for this sort of work in fresh water. As I said at the start, we were already looking at eels, so they were kind of an obvious choice, and they're a really good species for looking at long-term change because of their high lipid content, the way they live, and the fact that they're very long-lived. And we were also looking at trout, as I said, and there's a caveat, and salmon, sorry, and there's a caveat I should say, which is obviously they're migratory fish, so depending on when you sample them, the body burdens of chemicals might represent other environments than the freshwater environment. Okay, so this is a map that gives you an overview of the sites we selected, and I must apologise to anyone from Shetland because it's not on the map, because I'm afraid we didn't have any sites there. So this is encompassing all of the sites we had for the different species of fish and sediments as well. And it's colour-coded, it's a bit difficult to see, but the idea was that we wanted to cover a range of land uses, so agricultural catchments as well as more urban and industrialised catchments. We wanted to capture sites where we thought there was a good likelihood of finding fish, and we wanted to include some background sites that we thought wouldn't be as highly contaminated. And it's a 3-year rolling programme that we ran, and so we're looking at each site just once every 3 years, with sampling just occurring in the summer. And at each site, we'd look to take between just 3 to 5 fish. And working with colleagues in ecology, we produced sampling guidance so that we tried to ensure that when we did sort of electrofishing for fish, if we didn't get enough fish to actually do the sampling for that, do the analysis for that site, we would just put them all back because there was no point in doing it. And in terms of analysis, we were generally looking in muscle tissue, and we would try and normalise those concentrations that we got for the lipids of the animal. And I think we very rarely looked at otoliths to age of the fish, maybe just for 1 year. Okay, so on to some results. And this slide gives you an indication of the sorts of levels of detection we were finding. So you can see straight away, the blue, the eels, we're finding far more of these sorts of contaminants. So on this slide, you've got the polychlorinated biphenyls at the top left, the polybrominated diphenyl ethers, top right, and then collection of pesticides in the bottom right. And for the PBDEs, these are flame retardants, basically, which were used for many years, and some of them are only recently banned in plastics and textiles and all sorts of things like that. And we found that the commercially more prevalent types of these things were more highly represented in our monitoring, as you might expect. We also found quite high levels of those in salmon and trout as well. Okay, thank you. So this is kind of similar data, again, just looking at detections, not concentrations, where we've split the data out by what's called SEPA, what's called the Water Framework Directed Advisory Area Groups, I think. So it's trying to give an indication of where we're finding high levels of detection. So you can see there's obviously a pattern. The eels are much more prevalent in terms of detection. And we're also seeing that the Clyde and the Forth, we're finding high levels of detection, as you probably might expect for polychlorinated biphenyls, which is what we're showing here. I haven't done a slide for the other chemicals because we didn't really see any obvious pattern for those. Okay, next one, hopefully. Fire away when you're ready. I don't seem to be doing it with this. Right, so on to concentrations. We looked at various measures of PCBs and these polybrominated diphenyl ethers, and what we found that concentrations were generally higher in eels. We did find high variability, which you expect when you're looking at chemicals in biota. And as you might expect as well, we found higher concentrations in agricultural catchments for the pesticides and higher concentrations for the more kind of industrial chemicals in urban water bodies and catchments. And yeah, as I said, I think that eels had significantly higher concentrations in general. And looking at concentrations from the literature, when we lipid normalize the results, we find that the concentrations we're seeing are kind of similar to concentrations that might be causing impacts in eels, for PCBs and PBDEs, which are associated with endocrine activity, so affecting the hormone system of the fish. But, come closer, all right, thanks. It's not all bad news. We were able to look at trends in data in eels as well, and we do find good evidence for declines in many of the phased-out pesticides. So DDT on the left there, we're seeing statistically significant decrease in concentrations. Unfortunately, not so much with PCBs, but levels were much lower for those. And hopefully the final slide. So in conclusion, we're commonly detecting these persistent organic pollutant type chemicals in freshwater fish, with concentrations and detection levels generally higher in eels than brown trout. There's some evidence for declining concentrations, and we're seeing similar concentrations to other data from Europe. And yeah, in general, we think that this sort of sentinel monitoring of the environment is really useful in understanding scales and levels and concentrations across the water environment of these sorts of contaminants. But we do think there's a need to improve our approach. And as you probably, I suppose, those of you who are more familiar with these sorts of contaminants, there's definitely a need to look at what's coming through now, chemicals like PFAS and these sorts of things where we've not done much work to date. And we also need to think about other methods that don't involve destructive sampling of fish. And that's something we're working with partners across the UK on. I think it's just one more slide and then I'll stop. But yeah, I should say I'm really just representing the work of many others in SEPA over the years. So it's not probably possible to name them all because there's quite a lot of people who've been involved with this work, from the sampling through to the analysis and data interpretation. And also we received a lot of advice from other organisations across the UK, not just in Scotland, which we were really grateful for. So thanks for listening. I've included a couple of references there in relation to impacts in eels from these sorts of chemicals. Thank you.